So now that we've completed our frequency table, we looked at the data, broke it up into intervals. We can take those intervals and make a new type of chart, which is a histogram. A histogram looks very similar to a bar graph, but there's a couple things about a histogram that make it a little different. In a histogram, it's typically used with intervals, and the intervals are what make it different because a bar graph is usually used with categories. Because they're intervals, the bars should be touching but not overlapping because we're kind of showing that it flows right into the next. You know, if your intervals were about hours, we're saying that, you know, this is 1 to 5 hours and the next one is 6 to 10 hours or whatever. So they should be touching but not overlapping. You also want to make sure the bars are of equal width, just like a bar graph, so that you're not misleading anybody. And of course, always remember to title your chart and your X and Y axis. So using our frequency table, and you have yours right above, you can look at it, but using our frequency table, we're going to put this into a histogram. I'm going to get my frequency table right next to it. Oops, sorry, that's the wrong one. Let me get my frequency table. All right, so here's our frequency table that we just came up with. We're going to put this into a histogram. We're still talking about the season scores from USC and Mount Lebanon, so let's title first. I like to do that first just so that we don't forget it. Now on a histogram, the frequency is going to be your y-axis, and your x-axis is going to be whatever your intervals are about. Our intervals are broken up, are categorized into scores. Okay? We have 1, 2, 3, 4, 5 intervals, so we're going to need 5 bars. So try to break it up evenly. And they're going to go right next to each other. So this first one is going to be 0 to 9. You got to put your interval right on there. Then 10 to 19. Then 20 to 29. 30 to 39. And 40 to 49. The highest frequency that I have in one of these intervals is 8, so just make sure on your y-axis you leave room to get up to 8. All right, in the first interval, 0 to 9, you have 1 number in there, so that's going to be my first bar. If you have a ruler, it's great to use it, make it nice and straight. In my second category, I have 8, so that's going to be my one that's going to go all the way up to 8. And the bars are going to be touching but not overlapping. The next one, 20 to 29, I have 6. 1, 2, 3, 4, 5, 6, 7, 8. A little bit of wave there. 30 to 39, I have 3. And then 40 to 49, I have 2. So it's just like a bar graph, but we use it with intervals, and because we're using intervals, we make the bars touch. Remember your titles, remember to label your axes. The last thing then is a cumulative frequency table. And a cumulative frequency table is going to build right off of your frequency table. So you may need to pause for a moment to copy down the frequency table that we've already created. Notice all I did was add on one additional column right here, and that's going to be for our cumulative frequency. So if you need to pause to get the data down about the frequency and the interval already, that's the same chart we've been using. Go ahead, I get to just take a picture of mine and pop it on here. A cumulative frequency table allows you to keep a running total of the number of data values in or below a certain interval, and that's kind of why they're helpful. So we're just going to add up all the frequencies we have at that point. So the first number here, after interval 0 to 9, I only have 1 data value. But after this interval, that means it's after the 0 to 9 and the 10 to 19, I have the 1 frequency here and 8 here, so I have a total of 9. Or you're taking whatever you had and you're adding the new number of frequency to get your cumulative frequency. After the 29 interval, that means all the numbers from 0 to 29, You can add up all three of these, or you can see it as I take 9, I add 6, I get my answer. After the 39, so all the scores below 39, including the under intervals, add all 4 of these up, or take the 15, add 3, and that gives you 18. And under 49, we're adding 2, gives me 20. So the last column of a cumulative frequency table is just how many numbers, how many data values have you had up to that point. We just keep adding on the new ones in the next interval to get the total. The nice thing about a cumulative frequency table is if you polled 100 people and you had 100 results, you wouldn't have to sit there and count them all. A cumulative column is going to show you at the end the total number of data values that you had. The other thing that might be helpful is if you're asked a question about percents. If I asked you this question, 75% of the game scores were less than blank points. Well, if it's less than a certain point, you can kind of see the percent because you can see the total. If we have a total of 20, what's the score that 75% of the games had less than? Well, 15 out of 20, right, is 75%. So there were 15 scores under what, 15 data values under what score? Under the 29. So there are 75% of the games that had less than 29 points, if that makes sense. This happens to work out really nicely because the 15 out of 20 is 75%, and that was the question that I asked. I could ask you about 50% of the data values were less than what score. And then we could see for the 50% that, 9 is pretty close to 10, and 10 is half of 20. So 50% of the game scores were less than 19 points. So kind of summarize what we just talked about there. In the right about below, does a cumulative frequency table give you any more information than a normal frequency table? Just a little bit. Where is it helpful? Explain that down here, and that's what I just talked about with this percent example and why I circled the last number in the cumulative column. Then you're ready for your quick check.